go on with second part of chapter 6. Now we have of course we have analyzed trusses, and now we go on with frames and machines. So the difference between trusses and frames and machines are that in trusses, that all trusses are all members of trusses are two force bodies. Let's look at the previous page. On the previous page, we have AB is a two force body, BD is a two force body, BE is a two force body. All members are two force bodies. Now we go on with frames and machines. In frames and machines that we have multiple force members, maybe 3 force, maybe more than 3 forces members, and the difference is that frames are rigid bodies and machines are not rigid bodies. Frames are rigid bodies and machines are not rigid bodies. For example, let me give you an example that a frame looks like this. A frame looks like this. This is a we have let's say we have one piece and one member here, one member and one member here. That it has an A shape. That it is a rigid body. And for example, that for a non-rigid body, let's go to page 52. Page 52 is a, we call it hydraulic lift table. On page 52, we have a hydraulic lift table. Hydraulic means this one, and hydraulic lift table is you can see from your motorcycle power repair shop or motorcycle repair shop. So it is for, so you put your motorcycle here, and you put your motorcycle here, and it goes up, and it can go up or down. So this is not a rigid body; it can go up and down. So this is a machine. Okay. And for frames, frames are rigid bodies, and machines are not rigid bodies. So let me mark them down, and so we go back to this frame is a rigid body. So let me write them down. So and frames are rigid bodies. You can look at page 50, and machines are not rigid bodies, and you can look at page 52. It's okay. Now, and for problems that we have for different structures that what we determine are different. And in trusses that we determine the forces in members, right? And we mark our answer in T or C. So T is, what does T mean? T is tension, and C is compression, right? And so we go, you can look at the pages 46 to 48. So in trusses that we in all problems that we determine the forces in members, either they are in tension or in compression. But in frames of machines that we look at the forces between members. I will explain it in a minute. That we determine forces between members. It's okay. We analyze forces between members. And you may ask if we analyze forces in members in frames of machines, that later we will do this later, forces in members, that we determine forces in members. I'm not sure if I've time that it will be in chapter 7 or in the mechanics of materials. If I have time that I will talk about this in chapter 7. If I do not have time, that when you study mechanics of materials next year, that you will learn about this. So mainly in this chapter that we determine forces between members in frames and machines, and in trusses that we always determine forces in members. Now, and for the standard procedure for the SOP, then of course we remove supports and put support reactions. Of course, we remove the supports and put in support forces. But there is one thing. There's one after you put in the support forces, that make sure that we analyze rigid bodies only. Okay. So in the free body diagram, the thing you are showing in the free body diagram should be a rigid body. I'll give you an example in a moment. Okay. If we in a free body diagram, okay. In a free body diagram, remember that we put in a rigid body only. If it is not a rigid body, that break it down into rigid bodies. That breakdown means so if you see the structure is not a rigid body, let's break it down into rigid bodies. Now let me give you an example here. Example is here. So we have a frame, and we have a frame here. So we have two members. We have a frame here, that AC and CB. Why do we say it is a frame but not a truss? Is this a frame or is this a truss? So for the structure on the left, that is this a frame or is this a truss? When do we say something is a truss and when do we say something is a frame? Let's go back to the top of the page. Let's go back here. That trusses are two force bodies, and if the members are not two force bodies, that those are frames. Okay, two force body. You need to remember what the two force body is, and and we have if we have multiple force bodies, then we have frame. We then have frames. So, is this a two force body or is it a two force body? The answer is no, because from what we see here that we have forces acting on C because this is a joint. We have forces acting on A because A is a what kind of support is this? What's this kind of support? We have usually a roller or pin, right? So this is pin support, right? So we have pin support. So we have forces at C and we have forces at A, and we also have force at this point P. So this is a free force body. So this is a frame, this is not a truss. Okay. So can you get this? That in trusses we have only two force bodies, but if we have three force bodies or more than three forces, that we have frames. Now, and to analyze to draw the free body diagram, that's the first step you may draw is something like this, right? So we remove the supports, and we have this one. And we have this. And here, let's look at how many unknowns do we have. Let's look at how many unknowns we have. So we have on the left hand side we have a pin joint, so we have AX and AY, and on the right hand side we have BX and BY here. So we have how many unknowns? 4 unknowns. How many equations do we have for equilibrium? Summation fx equal to 0. Anything else? Summation fy equal to 0. And the summation m equal to 0. So we have only 3. But we have 4 unknowns. Now we have 4 unknowns and 3 equations, so we cannot get all results. So this is not the way to go. And we have you can see that is this a rigid body? Is this a rigid body? If we only look at these two members, is this a rigid body? Because this is a pin joint, it means that we can go this way, right? So this is not a rigid body. So what I've said in a minute ago was that analyze rigid bodies only in a free body diagram. So if it is not if a frame or machine is not a rigid body, break it down into rigid body. So here we have one rigid body and 2 rigid bodies. We have 1 rigid body and 2 rigid bodies here. So we have 2 rigid bodies here. So we have So we draw a free body diagram for each rigid body. We draw a free body diagram for this, and we draw a free body diagram for CB. Now, how many unknowns do we have here on the figure? Because P and Q are known. So we have AX and AY, and BX and BY. And because we have forces acting from the right hand side to the left hand side, we have CX and CY. And by action and reaction, that we have minus CX and minus CY. So we have 6 unknowns. We have 6 unknowns. Now, how many equations do we have? On AC, we have the three equations. We have summation fx equal to 0, summation fy equal to 0, summation m equal to 0 on AC, right? For this free body diagram. Now, on the right hand side, we can write another 3 equations. Let me write it down. On CB, we have another 3 equations. So we have another 3 equations that we can write for the free body diagram of for the member on the right. So in total we have 6 equations, and we have 6 unknowns. So we have we can solve the problem. We have 6 unknowns and 6 unknowns and 6 equations now. So we can solve for these 6 unknowns. And so take your time to write it down. And I will explain how to do this in the example. If I see most of you are okay, then I'll go to the next page. Now we go on with sample problem 6.5. So determine the components of forces acting on each member. So we are not determining the forces in member, it is acting on each member. So we are determining the forces between members, okay? It is acting on each member from other members. It's okay. Now, and for this type of questions, the first thing you do is the same as in clusters. And we draw the free body diagram of the whole structure. We draw the free body free body diagram of the whole structure, which means this one. So this is A, B, C, D, E, and F. That to give a quick look, that we have forces here, here, and here, and here. And you mark the dimensions, right? So first of all, you draw the free body diagram, and remember in the examinations coming on that you always need to draw the free body diagram before writing equations. And is that okay? Now, if you are fine, then I'll stay here for a minute. And then after drawing the free body diagram, you guess the support forces. So these are from chapter 4, and if you are not familiar, or if you are if you are not familiar with this, that do more exercises on this. Entire frame means entire means whole. Okay. Entire frame means whole frame. Okay. Here. So I think you can do this, right? So you take the reference point at E, and then so moments, find some moments that you can get E. So you can get F is equal to 1,800 newtons and so on. Okay? Now for the next step, similar to trusses that we break it down into members on this case. So we need to determine forces acting on members from other members. So we go on that because we are working on forces acting on members. So we work on we draw the free body diagram of a member. So the key point here is that, let's say we analyze A, B, E first. A, B, and E. I should do it. Sorry. How should I do it better? A, B, and E in the middle, right? So before you draw the forces, is this a rigid body? You need to confirm it is a rigid body. Okay. Check or double check or confirm. So you need to confirm it is a rigid body. If it is not a rigid body, what should we do? We break it down into rigid bodies. So this is the rigid body. So we can do work on the other. We can go on to draw the other parts. So here we have first of all that we have EX and EY that we have solved. EX is equal to 0 and EY is equal to 600 newtons. And we got this from part B, right? Let me draw the dimensions as well. Sorry, that I think I'm sorry. I marked the figures wrongly. So please sorry that it should be 2.7 meters. Sorry, here I forgot why I wrote them as 3 meters. So please correct this for me. These are 2.7 meters. Okay. So if it's okay. Now if we have so we have 2.7 meters here. So we have now because for this APE that there are other members connected to node B, for example, at joint B. So it has forces acting on joint B. And this is a pin joint, so because these are pin joints because we have BCD, right? And this is a pin joint. So we have this BCD cannot move to the left, it cannot move to the right. Can BCD go up and down here? Can it go up and down here? No, it cannot go up and down. But it can rotate. So for BCD, it is fixed here. It can go up. It can rotate like this, but it cannot go left or right. It cannot go up and down. So we have two forces here. Because it cannot go left or right. So we have force in the horizontal direction. We say Bx. And it's okay. So we have because it cannot go BCD cannot go left or right, so it has to be here. It is staying here. So can it go up and down? No, it cannot go up and down. So we have a force in the vertical direction By. Can BCD rotate about point B? Yes, it can rotate about point B. So we do not have a. So because BCD can rotate. So we do not have a moment. Okay. Because it can rotate. So we do not have a moment. So is that clear? That so we get these two reaction forces. Now we go to point A. For point A, then we also have because we also have we also have a pin joint here, so we do the same thing. So we have AX and AY. So what I have done here, sorry. So we have AX and AY. Now we have, how many equations can we write from here? How many equations can we write from here? Summation f equal to 0, right? So how many equations can we write? As usual, we have 3, okay? We have 3 equations. So we have summation fx equal to 0, and positive to the right, and we have summation fy equal to 0, positive going upward, and summation m equal to 0, and let's say we take a point, which point? Let's say mp equal to 0. Counterclockwise is positive. In examination, remember you need to write. I think it is very good to write this. Okay, if you write something wrong there, then I still know where your equations come from. Now, and for fx equal to 0, that what do we have? We have ax plus bx plus 0 equal to 0, right? Because ex equal to 0. And we say this one. And the second equation is summation fy equal to 0. That we have 3 forces in the y direction. So we have ay plus by plus 600 Newton equal to 0. And for mp equal to 0, summation mp equal to 0. So we take point P as the reference, and for this one, that we don't need to consider the moments. That we don't need to calculate the moment, and this one we do not need to calculate the moment. And this one is equal to 0, so we do not need to calculate the moment, and we only have this one. So we only have one force to consider the moment. I think you know the word consider, right? Consider or take into account means 考虑. So here we have, so take your time to write them down. Now, here we have 3 equations. And how many unknowns do we have here? How many unknowns do we have here? We have AX, we have VX, we have AY and we have BY. So we, of course, we cannot get everything from here, but it is okay. This is fine because we have other free body diagrams to come in the next step, right? So, but from here we know that because from this equation we know Ax is equal to 0, and then from here we know this one is equal to 0, so this one is equal to 0. So, and I usually do this. And we have equations 1, 2, and 3 here because we have more equations to come. So I would say from 1 and 3, Ax is equal to Bx is equal to 0. And of course, we have not determined we have not solved Ay and By. So, and then we can do this later in the next step. Now, and so the next, then we go, because we still have AY and BY to solve, and therefore, and we work on the next, we work on with the next member. So before next Tuesday, please help me with this. So, and let's talk about member BCD. Now think about how to draw the free body diagram of B, C, and D. And the first thing the first thing to look at is that, so at point B is the joint between ABE and BCD. So now by action and reaction, that's the force acting from BCD to AB is to the right, so this one BX is to the right, so this is action. And so what's the direction of reaction of BX? This is action, and this is reaction. So reaction goes to the left. And for action, for BY as action, it goes up. BY goes up. So for the reaction, that BY should go down. Let me write it here. Oops. Let me put a box. So please, before next Tuesday, please help me to draw the whole free body diagram, and I will start from here on Tuesday.